My name is Gideon Edelbaum, and I start work with the Institute in 1956. That was after Sinai operation.
After the Sinai campaign.
Yeah, and I left the army and I was an electronic technician, and I remember some technician was required here in the Institute to maintain the Weizac. You remember the Weizac? That's the first automatic computer in the Middle East. After I don't know how many years.
We discussed the Weizac a couple of days ago, so it's on tape already. You needn't talk about that.
Okay. Then I served as a maintenance technician with the Weizac until you came.
That's right. Well, okay, I don't think I need to introduce myself again. So, in fact, after this round, I'll start to say something maybe about each one and how I met them and what they started doing. Ami?
I'm Caspi. I came to the Institute in 1961 after graduating in the Technion. Actually, I came as a maintenance engineer for the Weizac.
That's what you thought,
yeah.
But it wasn't true. No, you didn't come as a maintenance engineer. This I can tell you, but okay. It's interesting that you think you did.
This is what I was told. But very soon I started working on Golem A, circuit design and logic design and many other things.
That's true. Reuven?
Well, this is Reuven de Roos. Came to Israel from Holland in '56. After working for a few months in a radio company in Israel, I came to the Weizmann Institute. The interesting thing is that when I came here in uniform, sent by the army to the computer.
I remember that.
It was in '57, and started first on the Weizmann. That was the. This should be recorded to it, right?
Has it always been like that?
At 10 o'clock, yes. About 10, very many.
Well, we should have asked them to divert the planes this morning, but we forgot.
Well, you should have shifted it until between 9 or...
No, let's say it's not 10 yet, it's 9:25. We'll finish before 10. They're not going to bother us.
Okay. So I started on interfacing the Weizac computer to tape handler's drum, famous drum, and very soon we switched to the initial phase of the Golem A computer.
Well, you actually worked on Irma, and the Irma memory for a while.
Yes, okay, this was another thing that we got the memory, and we did some interfacing, and then we started on the Golem. I think this is the time not to talk about the Irma memory and so on.
Well, they did mention the Irma in previous discussion. Yeah. So maybe I'll say now how I saw these people come into the picture myself from my point of view. Well, as Gideon said, when I arrived, he was doing maintenance on the Weizac, and he was the first one of the maintenance technicians to be taken off that and put on the development of the Golem A. And I think I'm not sure now, but it seems to me that we built a little piece of a 4-bit slice of the Iliac 2 with their boards.
I know where it is.
With their boards,
Smil.
and
I know where it is. You
have it in your
I know you.
in your junk box. Okay, yes. I understand. And the first thing we did was put this together and put it on and ran it with a Fibonacci series or something. And then we started working on, I guess you were also the first person to start working on layout for printed circuits. Maybe you can you remember what the status of the printed circuit etching machine was at the time? It seems to me you were the first one to work on that too. Later, Aryeh Ramon worked on that.
Yeah, I think I built it.
I see. Somebody told me that it was the man in charge of the maintenance of Weizac, Krasnitsky, Mika had built it, but I'm not sure.
He was not.
Okay, you built this, designed it and built it.
Yeah.
That's the garbage can we talk about that the machine was built in. So maybe you can describe the history of it and how it worked.
It was made out of a garbage can, a big garbage plastic can. It was a tube in the middle, a perforated tube, and a motor, and a cover, and sort of.
There were fins at the bottom which acted as a pump, pulling the.
That was pump the acid.
Bring the acid up,
all over.
Spray it.
And we hang all the boards on the
around the
can.
periphery.
And that was it.
And we could do 8 of them at a time or something like that.
8.
Yeah.
Do you have a picture of it, or do you have it?
No, it's been thrown out.
I
think we sold it. We sold it to somebody. After we made both computers. To be used. Yeah. In those days, there wasn't any facility then in Israel. Is that right?
No.
As
a matter of fact,
this was the only way to build it, to do it yourself. You made some, but we found that it wasn't uniform, and it had all sorts of little problems which we fixed up by
later.
Yes, in time for the production of the Golem.
The point was that. We were not familiar with all the problems at the beginning, and I think it worked after the 3rd version, something like that. But then it worked for years.
That's right. And eventually we built a second one. I think I did that with Aryeh. Maybe it was in the same can, but the whole works was new. A new shaft. It was a hollow shaft, also from plastic. Well, maybe we leave this for a moment and we go on to Ami for a bit. The way I remember Ami starting is as follows. When I came, there were 2 engineers, aside from Tzvi, there were 2 engineers on the staff. One of them was Reuven Deros, and the other one was Yuda Sivan, and they were both assigned essentially to Weizac and additions to Weizac and things like that. So, first of all, we couldn't take him off right away because Weizac had to continue working, and secondly, it didn't seem like enough staff to get started on development of a machine. So we looked for 1 or 2 engineers, and we put out an ad in the paper. And every engineer that fit the requirements in Israel came to be interviewed. I think we had something like 100 people. Or I wouldn't commit myself, but perhaps between 50 to 100 certainly. And we took the best 2, and Ami was Ami and one other, Yair Tur. Yair Tur indeed went into maintenance, and he's no longer with us. So this is how we got Ami, and it was not at all for the purpose of maintenance of the Weizac that he was hired, even though he may have had that feeling. And maybe now we turn a little bit to the circuit problems. And in fact, when we discussed the development of the Golem, we said that maybe one of the major one of the major innovations, and that what made the Golem possible, or made it as good as it came out, and what was the technology, the circuits. And the two people who helped me design the circuits were Reuven and Ami. Ami really got into every facet. He very quickly, even though he was just came out of school, he very quickly moved into everything, into hardware, into programming, into you name it. The person who stayed with the circuit design, I guess all the way through, was Reuven, really. Perhaps it's being recorded all the time, even though Richard is not here, so we can continue. Would you like to say anything about the way things looked to you during the development?
It's not so easy to recall. It's a long time, but
maybe I'll prompt you a little. If you remember, the thing we started with was the first experiment was to build a 4-bit slice of the arithmetic unit and run it with a Fibonacci series. And not long after that, we had the whole arithmetic unit running with a Fibonacci series. And in fact, the thing which I related, which I don't know whether you'll back me up on that, is that we built the whole the main arithmetic unit, the floating point arithmetic unit of the Golem A, and put it together, and it all worked. There wasn't an error even in it, either logical or reduction error.
Yeah, the Fibonacci test, I think, worked when we...
The first time. You turned it on and it ran.
Everything.
Now, I remember, though, that there were problems in getting started, and that is when we first got some cards, and we had to test cards, so we started to put them in. In fact, the Fibonacci, the 4-bit slice that ran the Fibonacci series also served us as a tester because we had no tester. So as we made more boards to make up the arithmetic unit, we put them into to this 4-bit slice and tested them. And we did have some problems. So I remember one of the biggest mysteries was that we found some diodes that had failed, and then we would go and fix them, and the next thing we knew is we got worse trouble. And for a while it seemed like a mystery, except we found very soon that the soldering iron was not grounded, and there was enough pickup that it would burn out the diodes. So the more diodes we fixed, the more failed. And this, once we found that, the mystery still, it didn't disappear. And what it turned out was that when you try to, before you can insert replacements, you want to clear the holes of the solder and other things that had accumulated. So we used a small drill to do that, and it too wasn't grounded. And the person who was drilling held the board with one hand and this with the other, and he would also burn them out. So this, in fact, I remember as the major problem.
I have some correction to make.
Yes?
Before we had the tester, Ami and me were the tester. We used to test cards, remember that?
That's what I was saying, that you would put them into this 4-bit slice and test the cards. You mean visually?
Visually and
sure, we did.
And used to bet on this resistor and that diode. And
yes, but until you put it in, you wouldn't know whether it was working, so you had to test it, even if the test came in the system.
I remember that when we wired up the Fibonacci tester, I tried to optimize the connections, and I had a drawing with all the wires going from one card to the other. It was a big work to draw all the wires.
I see. So I thought it was rather simple. But
No, because
But then I didn't have to do it.
we wanted to optimize the wireless.
Oh, you mean to make the connections as short as possible? Sure. Well, the other thing I wanted to talk to you about was about the memory. I don't know how much you were involved in the first memory with Indiana General. I think Yuda Sivan helped me build initially build the tester for the memory and the stacks. But then you came into the picture, I think, and I would like to go over maybe some of the things I said. We talked about Indiana General the last time, and I would like to say that Indiana General really was, we put we wrote a specification, put it out to bid, and they were certainly the most energetic, and they certainly had the best proposal. And there was a man there by the name of Alex Elovic, and he was really a live wire. It was very helpful. The problem that I mentioned the last time, which had to do with, maybe you remember, we had a very fancy pattern that included the information pattern in each plane, as well as the sequence that we use to write and read and so on into these planes. And that this together charged some capacitor in the sense amplifier and caused the thing to fail. Now, this is not something that I can really blame Elovic. This is a problem, in fact, that he might have recovered from. Eventually, the thing which soured the whole thing and caused us to abandon it was simply the production problem, where these wires, the wires and the windings would short to each other because of impurities that had corroded them. Do you remember some of this? Did you do some of the? Did you have to troubleshoot the memory when it used to fail? And you remember there was another failure mode which many of the drivers would suddenly burn out. And
there was a very difficult problem, intermittent.
Oh yes, this I talked about before. Yeah, I guess we didn't. Yeah, that's right. I know you and Svi were looking for it for a long time. Until one day I came by and you told me what the symptoms were. And I had worked a lot on, well, not a lot, but some, on coincident current memories. And well, this wasn't coincident current. This was a 2.5D.
No, it was coincident 3D.
The first one? I'm not sure, but let's let it go. You may be right. It was the one for Golem
B.
No, it was also for Golem A. The one we got from Fabritech was certainly a 2.5D. No? No, the one we designed ourselves was 2.5D. The others were 3D. So I pieced the things together and I said, well, it's got to be that there's a short between two windings. And I told you which windings they might be, and indeed it was a good guess, and that was it. Maybe we go back to return to circuits with circuit design with Reuven.
Well, we tested several designs, I remember. We had to speed them up with feedback. Positive feedback.
Yes. No, you're talking about something else. We had a set of. I don't know at what point we can bring Marion in, but we don't have a chair for her, so maybe one of us will have to finish
before.
There is
another chair here, but I don't know if.
Yes, is it possible to bring it up?
Sure, bring Marion. Please don't knock the light over.
Where do you want her position?
Parallel to your chair.
But no, parallel. That's it.
Not perpendicular.
Or maybe you sit here. Make it easier.
So shall we introduce her now, or when when I finish with Reuven? Pardon?
Let him finish his sentence.
Okay. No, in fact, I was
You have to
talking.
finish what Smil said.
It was my sentence, but it's all right. You were talking. The feedback has to do with a capacitor feedback, which we used in the input-output. In order not to introduce new components in the input-output, and yet produce slower circuits.
This was a Smil run-up with the capacitor.
That's right.
Exactly.
We put in an external capacitor on the outside between the base and the collector to give you which acted by the Miller effect to slow it down.
Now this was the thing we speeded it up because we went to a 12-volt supply and cut it off with a
diode
cut it off at a certain level, intermediate level.
With a clamp diode.
Yeah.
That's correct.
I think I remember exactly how we started. You brought with you transistor samples.
Oh yes, I came with a sample case of transistors and diodes.
And Reuven
this
sat
incoming
down
inspection
and
it was a headache.
measured every transistor and its performance.
And we measured their and we compared. I had samples of all kinds of transistors and diodes that I brought with me, and then we out of these we then selected the ones that seemed most appropriate. But the diode was more difficult. In fact, in the end, it was made to our specifications, but of course it was based on the capability of some manufacturer to do that. So it was based on what they sent us with specs, final specs. Look, in those days it wasn't really a production spec. Just like they test integrated circuits now, and they give you higher performance and lower performance. And with diodes, their control in those days was even worse. And so they would make a diode which was supposed to hit a certain average, but the swing was so wide that they would then sell many types, which ranged all the way from high performance to fairly poor. And it was rather a matter of selection than of manufacturing.
Most important was the storage charge of the diode. One of the specifications.
One of them was stored charge. Perhaps the most important one was the stored charge. That's right. Well, maybe we can have Marion introduce herself now.
I'm the other half of Smil, and came with him to Israel. And after a year and a half, seeing that he was becoming more involved and knowing that we were planning to go back to the States, I offered my services. No, it was a year and a half when I started working. I offered my services for free, doing the drafting. I asked if there was anything I could do to speed up the finish of the in-house work so that we could go back to the States. And he said that he needed somebody to do the drawings. I had actually learned how to do electronic drafting in Philadelphia when the University of Pennsylvania ran out of funds for the MSAC or MSAC. So I volunteered my services, subsequently got paid for it, and I started doing the drawings half-time. And I think I did all the drawings of the Golem Aleph.
Yes,
by myself.
Marion knew that I tended to get involved, and then I wouldn't leave. I wouldn't be ready to leave on time, and she was anxious that we should go back when we planned, and so she asked whether there was anything she could do to help me stay on schedule. Now. So she volunteered her services. We were in fact looking for somebody, for a draftsman or a draftsperson, as they say now, to make up the final drawings. And she was certainly qualified to do that, but she started as a volunteer, and I hoped that it would stay that way. But then I found myself in the position where Chaim Pekaris said, well, she can't continue working unless she becomes an employee. You can't keep her as a volunteer.
So he didn't want to hire her.
And
anybody.
And then I found that Marion, in fact, the idea of working for a salary appealed to her. She had never worked for a salary, and therefore I found myself with this kind of opposition, both at home and at work. You can see who won out.
Did you actually learn much about electronics?
Actually, it got to the point with the Golem, Golem B, that, believe it or not, I took a course in Boolean algebra at the institute. I learned a tremendous amount from the whole business. First of all, not so much with Golem A. That I designed the panel. I did a lot of the bending of resistors and assembling of cards and soldering, and did all the drawings. But with the Golem B, without any question, I learned a tremendous amount. I designed some of the multi-layered printed circuit boards, but we're not discussing Golem B right now.
In Golem A, Marion being a fine artist, she was asked to help us design the panel of the console panel, and particularly the emblem Golem on it. And she did a lot of critical jobs. Not only the drafting, which she did very nicely, but a lot of fine assembly jobs. And we did mention the last time a girl by the name of Nechama Sharon, who had just come from Romania. She was a new immigrant from Romania, and she helped us a great deal in the assembly and the wiring. And Marion and Nechama were the ones who eventually, when we came to develop Golem B, and we couldn't find a core memory stack that was in production that was suitable. They made us an experimental. They sewed an experimental stack for us that Ami used to design the core memory for Golem B.
So in essence, I really did learn a tremendous amount. It was a marvelous experience, and of course the feeling in the department in those days was one of great excitement. It was a lot of fun. I really enjoyed it.
As far as since Marion brought up the assembly and construction aspects, there were a lot of strange things there. For example, some of the jobs which are rather routine, nevertheless they're very difficult. They seem to require certain aptitudes. I'll mention just two jobs. One of them was the drilling of the boards. Each printed circuit has maybe hundreds of holes. Now, most people get very bored with the job, and as soon as they do, then their speed and their accuracy goes down. But we had one fellow, Goel Budai, who continued to do this. In fact, he used to do it as overtime because he had another job during the day. But the more of these he did, the better he got, the better his speed and the better his accuracy. And in the end, he was drilling almost, even though there were several other people in this job, he was doing the bulk of the work. And a similar thing happened in the wiring. The whole machine, the backplane wiring was done by hand, by soldering. And it seems that most people have a problem. I know I've tried it, and I run into this problem. You have to remember the pin number, the socket number and the pin number that you start and the one that you end with.
You're talking about wire wrap.
Wiring. And no, in this case it wasn't wire wrap, it was soldering.
Oh.
So you start and then you either make a mistake in the first place, or you make a mistake in the place to which it goes, or you miss either the pin number or you miss the card number. And We had, for instance, one fellow I remember, Shimon Gilboa, who has hands of gold. He does wonderful things. He did a lot of work for Gideon. But he tried this job of wiring, and after a couple of hours, the guy would be climbing the walls because he would be so frustrated because he'd always make some mistake on the wire that he would just be climbing the walls. But Nechama Sharon, for example, she was a whiz at this thing. She, both in terms of accuracy and in terms of speed, and in this sense, she helped a great deal.
She really did most of the wiring.
She did.
She had the
so just like Goel did most of the drilling, she did most of the wiring.
That's a tremendous
really.
circuit taking.
Okay.
Tell another wiring story with, at lunch, I think with you, about going out to California and looking at one of the boards, and whenever you tested it, it didn't work, and the repairman came in and touched it, and it worked fine. Was that your story?
No, that wasn't my story.
Oh.
Someone else.
It was probably Jerry with the first computer. Should I go?
Well, it's up to you. You can stay until the end, and if you have time. In fact, we're not going to be much longer. So maybe we go backwards now. Maybe we come back to Reuven again. Is there?
What other jobs I did?
No, it doesn't have to be jobs. You can just think in terms of, as I said, things that come to mind that are interesting or.
Well, in a general sense, I think the Golem A was a very uninteresting computer because things went very smoothly.
I see.
You ran into some troubles. We had circuit troubles and the thing didn't work out. You calculated things through and you changed it and it worked. I don't remember anything very big and very disastrous which happened.
Well, one of your biggest jobs, if I'm going to prompt you a little, one of the biggest jobs you did was there was always a stage in the design of a computer where, if you're doing your own circuits or your own technology, is to make up the rules. And now you don't want to check every possibility because the possibilities are infinite. So what you do is you start with a few possibilities that you know exist, and then you start to expand to the things you think might be needed. And then you try it, and then you do layout, and then you come back and you try the cases which you hadn't predicted, which came up, distribution and so on. And this was your job, and in fact, in the end, we had, particularly with transmission lines, if you remember, the same circuit, the same standard circuit without a load resistor and diode would serve as the driver. As a transmission line driver with a connect.
Well, you calculated it through with some electronic algebra in order to get out overshoots and undershoots.
That's right, but in the end, in the end, you had some tricks also. If I remember right, I've forgotten what they called them, but they had these ferrite cores that used. They have a name for them. They use them. It's used for damping. It's a lossy core that you put on, and you put it on the beginning of the transmission line to prevent reflections coming back from getting back into the driver. And you had to work with those too, and eventually that was part of the rules. That in certain cases you would, they call them. I remember now. They call them slugs. Ferrite slugs.
Beads or slugs.
Yes. I remember one severe problem that we had, and we had to solve it with the slugs. There was a scratch memory.
You want to speak up a little bit?
I'll try to. There's a scratch memory. I don't remember how we.
Oh, in flow gating.
Flow gating.
That's right.
And we had 10 flip-flops on the board, and
there was a distribution line for the drivers or something.
No, and I made the layout, and he had room only for 8 at the bottom, and 2 he put on the on the second floor.
I see, and another level.
And then we had gates that went to all these flip-flops, and there was a tremendous capacitance on these lines, and it was very difficult to drive, and we had to make a special driver to...
We had to modify the driver to
modify the driver, and
to make it work right.
There was a severe problem of coupling between the gating lines.
You think the time was, so smooth and not interested?
Not interesting.
Let me remind you, I remember once you came back from Smil room, frustrated, that I'm working for 2 weeks on a circuit and I just came and showed him that it is impossible to do it. And he just changed one voltage, and in 20 minutes he made what I couldn't do in 2 weeks. Remember that?
No, I don't remember such miracles, but I do remember that having worked, when I came to the institute, I wasn't a supervisor. I was a supervisor, but I really was working on the bench and at the scope all the time. So when Reuven or even Ami would go and make an experiment or take some measurements, and he would bring me, and then we would sit down and look them over. I would often spot that there was something wrong, consistently wrong. That is, that maybe the scope was not calibrated, or something was off, or the conditions weren't what were called for. And without actually going into the lab, I'd put my finger on it, that this is wrong, or this is suspicious, and probably what it was, and he would go back into the lab and find that it was so. And I'm sure that frustrated him.
Well,
but
those things happen. Sure, if you go deeply into something, then you get entrenched and you don't see the surroundings.
That's exactly right. Exactly right. This is because you don't see the forest for the trees, because you are too busy and too tired working with the thing on the bench, and you don't look. Somebody who sits on the side and looks it over is much more likely to notice such thing. I agree with you entirely. Did you have anything more to say, Mariam?
No, I just remember the labors. I remember Gideon and Aryeh with the first boards taping, and the first film that was made, and all of the first. It was really traumatic. Everything that happened.
Yes. In fact, I didn't mention that at all. The layout and the taping, the photographing.
This was a tremendous undertaking to start.
That's right.
You take it. You're talking about the logic, but you have to remember that the physical building of it was really quite innovative.
Well, if I told
never mind the fabrication of the boards and the machinery to fabricate them. I mean, it was like from the Dark Ages.
Oh, that reminds me of another thing. But incidentally, you talk about the layout and the taping and the photographing. We had no facilities to photograph, and we went to the Matpisa Memshalti, which is the government printing press, which printed the money. And they were the ones who photographed these artworks for us. They were the only ones that had a camera that was good enough to have the accuracy we needed to do that. And luckily they didn't give out any samples, and we didn't give them any samples. I do remember that Yosef Dabi, who was there with us then too, that to keep good relations with him, he did used to give him small gifts that wouldn't be considered a bribe, like a calendar from the Weizmann Institute or some other thing that would please them. But this is how we did our. And there was something else you reminded me of, which I said I was going to.
What, the machinery for the manufacture of the boards?
Oh no, I was going to talk about.
Drum?
I was going to talk. No, we discussed that before you came. The thing, probably the part that I liked least, which I hadn't done before, frankly, and because in the States we always had a mechanical engineer who would help us with the packaging and the cooling Now we didn't have anybody like that, and I had to do it myself, and I had to learn this. And it turns out that it's a very poorly documented area. That is, if you want to know how to how to package and cool, particularly the cooling problem. How to
the fans, the whole
that's right,
air conditioning
and
of the
it's a
machine.
whole science in itself, and there was almost no information available. Eventually, I got a hold of a couple of articles written by manufacturers of these fans, and in fact, it's a good thing I got into it because the problem was much more difficult in Golem B. Golem B was maybe the only machine of its generation that was still air cooled. Because by then CDC was using Freon, and IBM was using cold water, and it was really a problem and a trick to be able to. I knew we had to use blowers at 400 cycles rather than at 50 in order to get the speed and the pressure we needed to do that. And then I think Reuven helped me with that.
Oh, we did some measurements.
That's right. I think
During this,
unless you can think of something.
You put your hand inside a box to take out a cable, and you took out a snake. It was you. And when I remember now, the drawing, all of these hundreds and hundreds of drawings for this computer, where do they put me? In the worst hole.
You talk about a hole. When I
And
came,
the mice, I used to sit there,
Okay.
freezing in winter, and
Okay.
the mice were scurrying
maybe
around.
we'll finish with a couple of stories on that vein. First of all, when I came, the room we sat in had been a cold room. It essentially was a refrigerator, a large refrigerator that was used by the people who lived in that section before, which I think was photochemistry.
Chemistry.
Yeah, and in this refrigerator we had 6 desks. All of us sat in there. So I don't think you should complain, Marion. But maybe I'll finish up with a story of the snake, which gives you it's connected with the way the building was built and so on. The computer room was built after was not built initially. After it was decided to build a computer, and I think after maybe it was with the contribution from Van Gren that the hall was built. And so it was an addition, and they didn't want to disturb the building, so they essentially built another wall next to the original wall, leaving a little bit of space in between. Now, since space was at a premium, they used that space, they put a door on it and used it as a kind of a closet. And in there we'd keep all kinds of stuff like old cables that we didn't know whether we'd use again. And naturally it was open to the ground since it was just a space between buildings. And that's where this viper crawled in there among the cables, and somebody pulled the thing out and just put their hand on it to grab it. Put his hand in and without looking and pulled out a viper. And I think we never killed it. It was given to it was captured alive. Somebody grabbed it you grabbed it by the head.
No, it's not my habit.
That's not your specialty. But I know it was sent to some laboratory for experiments, an experimental laboratory, because we captured it alive. I think on that note...
It was a carton box under the table. I put down the box. It was full of cables. And then I saw some very special cable inside.
Oh dear.
Okay,
But
I
it
guess
was fun. It really
it was
a
fun.
great
It was also fun to talk about it now,
That's
and
right.
thank you all for coming.
Well, thank you. Thank you all very much.
Thank you, Richard.
Let's see, we need 3 more releases.
Pardon?
3 more releases. We didn't explain any of that to them. See if I have any in here.
Oh, 3 more releases. You have to sign that you permit the use of this.
Well, it's the other way around, actually. Sing one here, because I forgot about it.
They say that they will not release it without your permission,
Right.
or of your ears. for the heirs after for 15 for the next 15 years.
I'll leave some with you when you go to.
Well, it's going to be a problem because Gideon
But I'll have to go get them.
Gideon is not with the institute. He should have said that. He took a part of his lab and he made it into a company.
Oh, well, why don't you talk about that for a moment, and then I'll go downstairs. Because that's interesting. What?
But this is part of the, you might say, of the things that came out of. But this was Golem B. And this was a thin film laboratory that we set up to, we expected to make our own circuits, thin film circuits for Golem B. And so we set up a thin film laboratory and Gideon was in charge of it. And eventually he bought the facility and made it into a company and he's running it successfully to this day.
Yeah.
So if you go get the...
All right, I'll leave this leaf aside.
Okay.
At least to save time.
Okay, unless you want to turn it off
before
you go.
This material is for historical archival purpose. We are trying to make it at the highest possible technical quality, considering the noise and everything else. And of course, with modern electronics, material can be enhanced and sound filtered out. So if somebody wanted to use it for a documentary or broadcast purposes, they could. But in that case, they would have to contact you. It's their responsibility and get your permission. All we're doing is making it available to historians. And so the release says it's okay for historians, but anything else has to be done with your permission.
No problem, unless it's not a candid camera.
Okay.
Maybe
Quickly get it.
Okay.
Just talk for a couple minutes.
So the camera is on, and you can talk a little bit now about the Golem B period and the thin film, and maybe what has happened since you set it up as a.
Well, as a matter of fact, I just want to talk a little on Golem A, even prior to
I had
that.
the key to my room.
Well, I did give it back to you.
You did?
No, maybe not. It's in my pocket. You're absolutely right. I'm sorry.
I'm gonna give it.
For some reason, I noticed that when you came to Golem Gimel, you went to Hebrew. You're still on being recorded.
No.
I have all kinds of ideas for advanced machines, but when, if ever, we will build such machines, I have no idea. I would like to build an associative processor. I'd like to build an array of processors.
funds.
But this, unfortunately, it's much more difficult now that you need to develop chips to do that, and we're working on that, but there isn't any immediate, I don't see any immediate prospect. I'm not sure we'll ever get to it. If such things happen, there may be special purpose machines which will be developed for industry initially, and maybe eventually make some more general purpose. If people came along and said they wanted a machine to predict the weather using an array processor, we would go ahead and try to make one. But we don't have any. We haven't had such a request, nor an appropriate
We don't predict
funding
the weather
to do
today
that.
also.
Pardon?
There is no weather prediction today either.
Well, that's because of the strike, but that's another matter. Gideon, you were going to say something about
I would like to interrupt you, but no, what I wanted to say is I remember the department before you came, and the atmosphere was not of industrious atmosphere. Things were.
it was more a
slow.
maintenance atmosphere with some upgrading of the machine from time to time.
Not only maintenance, I wouldn't like to mention names, but I remember
better
once that I have an idea how to save several microseconds in the shifting of the registers, and then the man in charge showed me that he had an idea to save maybe, 100 times as much. And I asked him, why don't you do it? He said, well, to start with, it's so complicated.
In other words, there wasn't a spirit of adventure or of
Something like that. But I remember you not only as the conductor of the computer building, but also as a teacher. You teach us how to work, how to overcome problems, how to take things in hand and do it.
Well, I had some good teachers myself. I think the main thing that I tried to teach you was that the best way to do things is to do them right the first time. In fact, that is a secret that many companies in the States didn't possess, and maybe some of them don't have it to this day. The idea, it's just like people write programs. They write programs, they said, well, there will be mistakes, we'll find them. Well, it's much better to try and get it right the first time, because it's true that there are ways of fixing errors in a way that makes the thing come out better than it would have come out if you hadn't made the error, but that's rather hard, and you can't do too many of those.
How did the automated system work?
I don't know. We had a sort of a free discussion, and maybe not about the things we intended, but that's the way it is.
I only could find one release, but it's perfectly all right if you all sign it. Just put the date on it.
Okay. Well, I signed one already.
You signed one
so
already. You didn't sign one.
it says exactly what he said. I read it before, but you can read it for yourself. And
That's all right. I say anything else.
I didn't realize it at the time, but I guess the Golem, when it was finished, was the only one of that speed in the world at the time.
27?
yeah, we discussed that, and we discussed the comparison between it and other. But it's hardly. You can hardly tell what your name is because it's just a scribble. I wouldn't know who signed it and who didn't.
I would.
Okay, maybe you sign maybe below the date, because otherwise we won't. He identified the scribble by writing it in capitals.
Oh, it's yours?
Make sure you get the pen out.
Is this mine?
Yeah. Okay.
That's it.